Hey, all of you, hope you guys are great. So, I believe that you guys are enjoying this token staking Dapp project. And in the last video, we have written our custom ERC20 token with extra features. So, if you haven't watched that video, make sure to watch it. That will give you a better idea that how you can build your own custom token with more data. In this video, we will write our contract for token staking, and this one is the most important contract in our staking Dapp, which going to provide all the feature of staking, reward, and withdrawal, everything we're going to do in this particular contract. And all the contract we have built previously, that's all we're going to utilize in this token staking contract. So make sure to watch this one. So here I have opened the token staking file, and in this we're going to write our token staking contract. So let's provide the license identifier. Let's declare the Solidity version, and now we have to import couple of files. So all the contract we have built, that's all we're going to utilize it right now. So first we have to import our honorable contract. The second import we have to do our reentrancy guard. The third import we have to do our initializer, which will allow us to check whether the contract is initialized or not. The fourth contract we have to import is the ERC20 interface, which will allow us to transfer the fund staking. That's all we're going to do. So these are the four contract we are using. Now we have to write the contract. So we'll call it contract token staking. You can give any name you want. And now we have to inherit all this contract into our contract. So this is the is keyword. Again, I believe that you guys have followed the complete Solidity course, and that I have explained every single thing about all the keywords and which I'm using here. So let's import the honorable, then we have to import the reentrancy guard, then we have to import the initializer, and that's all we have here. We have the abstraction, so we have inherit the abstraction. Now we can come here, we have to take the struct to store the user details. So let's define that one. We'll say struct user, and we can provide couple of information. We'll provide the UNT, like stake amount, then we can provide the reward amount, then we have to provide the last staking time, so when they have staked the token last, and we have to provide the reward calculation time, so when the last we have calculated the reward. Then we have to take this reward claim so far, so what amount of reward he or she has taken out of it. So this is the entire user struct we have. You can define more data, but these are the basic information we try to keep in the contract. And now we have to define that what amount of token we allow user to stake in the contract, or what is the minimum staking or what is the maximum staking. So let's define the minimum staking 20. Minimum staking is going to be any number, it's totally up to you. Then we have to define the maximum staking. So maximum staking token limit for program. I'm just giving this comment so you guys can keep in mind that what variable we have taken for what. So because this one is the most important and the biggest contract we're going to create in the staking Dapp, so that's why I'm providing this comment, so you guys can refresh, you can come back and you can watch, and you guys can identify that what variable defining for what. Let's come here, we have to take this another one. We'll say staking end date, then we can come down, we have to take this staking start date, so when it will start. Now we can come down, we have to take another one, which is the token staking, okay, total one. Then we can take this total users who stake the tokens, and we have to take this stake days, so what is the period, and this stake day will define that for how long you allow user to stake their token. Then we can take this early unstake fee, so this will be in terms of percentage, because if the users try to withdraw the fund without a token without the completion of the time, they have to pay certain fee for that. Then we'll take this boolean is taking pause, so it will return either true or false, means, and this particular boolean will tell us that what is the status of the contract, it's active or not active. Then we can come here, we have to define the token contract address, so we'll take the address, we'll call it private, and we'll define the token address. And this variable we're going to update at the time of initializer contract, so we're going to have a function in the contract which will initialize our contract. You can initialize at the time of contract deployment, but I try to keep it separate function for that, so everything will make sense, just follow along with me. Then we can take this, like the percentage of reward you want to provide, it's going to be unt variable app rate, Then we can take this public const percentage denominator is going to be this 10,000, and the second one will have this app rate change to 10. So this number is totally up to you that what reward you want to provide to the user, but this is the common denominator I have found in most of the contract when I was doing my research. So I would like to go with the same approach here. This one is the standard one in most of the staking contract. Now we can come here, we'll take this user address user. Now we have to build the mapping user private users. Now we can come here, we have to trigger the event stake event. So when the user will stake the token, we have to call this event. Then we have the unstake event address user and the amount, how much token they have unstake, means withdrawn. Then we'll have another one called early unstake fee. If they try to withdraw the staking without completion of the time, we have to initialize that as well. Then we have this particular claim reward. Then we can come here, we have to build the modifier. So we'll say when treasury has balance, it will take this amount, and in that we have to build certain conditions. So we'll say required, we'll say we have to take the token. So here we are using the ERC20 interface. In that we have to pass the token address, and we have to check the balance. It should be greater than 0, greater than the amount he tried to withdraw from the fund. If it has, then we have to allow them to withdraw, otherwise we have to throw this error message. So what we are doing here, we are using the ERC20 interface, we are passing the token address, and then we are checking the balance of the user, and then if it has, then we have to make the transaction, otherwise we have to throw this error message, insufficient fund in treasury. Then we have to close this modifier and we have to continue ahead. So this is the first modifier we have. Come here, let's build a function call. So this is the very first function we're going to call after we deploy the contract, and this will allow us to initialize, means start our contract. So user can come and deposit the token. So it's going to take couple of data. So it will take the address of the owner, then it will take the token address, app rate. It's going to take the minimum staking amount, then we'll take the maximum staking amount. It will take the UNT stake start date, and we have to provide the end date. And then we'll take this stake days, and we'll take the UNT early staking fees percentage, and we're going to simply call our initializer. So we are calling this initializer method we have, and in that we have to simply pass the data. So we're going to create this function called token staking in chain, and in that we have to simply pass all of the data. We have to pass the owner, we have to pass the token address, we have to pass the rate, we have to pass the minimum staking, pass the maximum staking, or we can pass the staking start date, end date, and the maximum stake days, and the early percentage fee. Make sure you have to follow the same order which we have followed. And here you have two options. You can define the owner of the contract at the time of contract deployment, or you can define the owner of the contract at the time of initializer. You have both the option, but for the safer side I would like to go with the separate. So that's the one we have here. Let's close that one, and now we have to build the function. So let's come here, we have to build the function called token staking int unchained. So this is the internal function we have defined in the initializer, and that's what we have to do. So we have to receive all of the data we have defined above. So we need the address, the token address, the minimum token app rate, then minimum staking amount, then we have the maximum token limit, we have the start date, we have the end date, we have the stake days, and the early percentage fee. So all of this data we have received, and now we have to simply call the only initializing. So this is the method we are calling in the initializer abstraction, and then we have to simply check for a condition, means app rate should be greater than this value. You can define any value, but I would like to go with this one. And otherwise we have to throw this error message if it's less than that. So app should be less than this. Okay, app should be less than this, otherwise we have to throw this error message. Then we have to do the second check. Staking days should be greater than 0, so we have to allow user to stake the token for a couple of days. We don't want to set it to 0 days, so that's what we have to set here. State days must be none 0. Then we can do the third check. We'll say token address is not equal to the 0 address, so means we don't want the contract, we don't want the 0 address, otherwise we have to throw this error message. Token address cannot be 0 address. Then we can do the fourth check. We'll say start date, it should be less than the end date, and that's obvious. So start date must be less than the end date. We can come here, we have to simply take this to transfer ownership. So this is the method we have, and that we're going to simply pass the owner. It will transfer the ownership of this particular contract. Then we take the token address to be the token address. We have to simply update our state variable. Then we'll take the app rate and simply update all of the data, minimum staking amount, and do the same thing for the max. Then we have the start date and update that one. Then we have to update the end date, then the stake day, and early unstake percentage fee. So here we have updated all the state variable we have taken. So hope you guys have understood that what logic we have implemented, how we are calling the transfer ownership functions, and how we are managing the entire state. And I believe that you guys are good in the state management, and if you really want to learn about the state management, then this is the course which I have on the channel. Take it. You will learn every single thing which you have to know as a web developer, and that will help you a lot in your web3 development. So this is the course which is absolutely must for you to learn about the state management and what are the tools and technology is the most demandable right now which you can learn to build your Dapp. Okay, so make sure to check, and that you will have the complete idea. Now we can take the create a view methods. So now whatever function we're going to write it will allow us to check all the data from our staking contract so we can display in our front end. So that's why I've called this view method start. Let's come here. So I'm going to make this comment so you guys can refer that what function is for what. So let's call the function minimum staking amount. So this will allow us to get the minimum staking amount. It will be external view return, and it's going to return the amount, which is a unity variable. So we'll take this return and we have to simply return the minimum amount. This is the first function. Let's write the second one. So function get max staking limit, and the same we have to return the unt, and we'll say return max staking token limit. So this is the maximum. Now we have to write the other one, date external view, it will return the unt, and we have to return the start day of the token. Close this one. Stake end date, and this will return the end date of our staking contract. So we'll take a function, we'll say get total stake tokens external view return, and it's going to return the unt, and we'll simply return the token stake total stake token, that how many token user have staked so far in the contract. We'll say function get total user view return, and return the unt, return the total user which we have in the contract. Get stake days view return, and return the unt. So how many days we have to stake our token. So this is our function. Early unstake per fee, which will allow us to display in our front end that if they try to withdraw the fund without completion of the time, we have to charge certain fee, and that's the fee we are going to display. Now we have to write the function for staking. So we'll say get status staking state, and it's going to return the boolean. So we have the data, that's what we can simply pass it here. So function get AP percentage, in that we have to simply do a couple of things. So we'll simply return the app rate, and that's the only thing. Now we have to write the function which allows us to get the estimated reward of a user. So in that we have to simply call this function, and it will return the estimated fund which a user will get. So this is the check we are doing. We are calling this internal function, in that we are passing this message or sender, and then we are simply returning his reward. Very simple logic. So what we are doing here, we are calling this particular method, and we are checking for the funds. We are going to create this particular function called get user estimated reward, which will execute internally, and is going to return this particular amount of the user he will earn the reward. Create a function called get withdrawal amount. So the rewards which user can withdraw, so we'll have to simply return this. So we're going to use this ERC20 interface. We have to pass the address so we can check the balance he or she has, and then we have to simply subtract the fund. So total staking, so total stake token, because this will keep the track that how many token user have stake in our staking contract, and when the user will try to withdraw, this is will display, and will simply reduce that one. These are the simple function we are building for getting the information from the contract. So we'll create a function we'll call get user, and in that we have to pass the user address. So it will give us all the details. So user memory, and then we have to simply return the user address, not the address. We'll pass the user address, and we return the entire information about the user. Let's create a function we'll call its staking holder. So this function will allow us to give us true or false. So this particular function will allow us to check whether a particular address is a token holder or not. If it's a holder, then it will return true, but if it's not, then it will return false. We have to pass the address, then we're going to call external viewer is going to return the boolean, and here we have to do the check. So we'll take this return, and we'll try to check compare it with this. Means if he has any fund in the staking contract, means he's the user, otherwise he's not the holder, and we have to return false. So this is the entire function we have written for the view method, so we can get the information from our contract, so we can display into our front end. This is the simple function we have written by one line, or you can take the entire information in a single function, but this is the approach which I would like to take, because we can call this function in multiple places in our contract, and we don't need to deal with all the data in the contract. Now we can come here, and we can start working on a owner method. So this particular function we're going to create right now, it's going to be controlled by the owner of the contract. So those are the methods we're going to create right now, like updating all the information in the state variable in the contract by the owner. Okay, he has the permission to do that, not the individual. So the very first function we have to create is update minimum staking, and that we have to pass the new amount, and we have to simply update it, and we're going to call this only owner modifier, because we allow only owner to call this function. And then we have to simply update that minimum staking amount to our new amount. Now we have to simply create a function which allows us to update the maximum amount. Again, it will take the new amount, and then we have to simply update that new amount. So this function will allow us to stake the end date. So we'll create a function we'll call update staking end date, and we have to pass the new date, and we have to simply update our state variable. Pretty good. Now we have to write a function for update unstake fee percentage, early unstake fee percentage, new percentage, and we have to do exactly the same thing. We have to simply update the new state variable. That's good. So this function allow the owner of the staking contract to stake the token on behalf of any users. So let's create a function called stake for user. We have to pass these two information, amount and the address. And then we have to simply update that, and make sure to call this no none reentrant. Okay, so no one can manipulate this to call the function. Then we have to simply update that. We call this staking, and we have to pass the amount and the user. So this will automatically trigger, and we're going to create this staking token function now, because this one is the most important function which allow the user to stake the token. So now we have to write the function which allow us to active and deactivate our contract for token staking. That's a very simple function. We'll say function toggle staking status, and it will only call by honor, and we have to simply update that one. So we'll say is pos to this means true, or they can be false. And now we have to write the function so the owner of the contract, staking contract, can withdraw the fund from the contract, because sometimes what will happen, that user will stake the token in the contract, but if they withdraw the fund without completing the period, the time staking time, the owner of the contract will charging certain amount as form of token. So we need to have a function in the contract so the user can withdraw the tokens from the contract to his wallet address. So let's create a function. We'll say withdrawal. We have to give the amount, and it can only call by the owner, and we have to check for the non-reentrancy. Then we have to check for a condition. We'll call this dot get withdrawal amount, and we have to check for the amount token staking not enough withdrawal. Okay, so we have to check for a condition. Then we have to call the ERC20, and we have to call the transfer method, so transfer the fund. And that's a pretty simple function we have here. Okay, so this is the end of the owner method, and now we can start working on the user method. So user can stake the token, and they can withdraw the fund, they can claim the reward. So many methods we have built, so many functions we have built, and now the comes for the users. So the very first function we have to create for the user to stake token. And let's create a function called stake, and in that we have to pass the amount. So they can only pass the amount and they can stake. So it's going to be external known reentrancy. We'll call stake token. This is the internal function we're going to create, and that we have to pass the amount and the message.sender. Then we're going to call this particular function called staking token, and this will be the internal function. So this function is getting called by the owner when the owner of the contract is staking on behalf of someone else, and when the user is staking the contract, we're going to call this particular function as well, because this particular function is entirely reliable for staking the token in the contract. Let's take this two information, amount and the address. Is going to be a private function. We have to check for a condition. The pause condition means the contract is still taking the token. That's the first check. Then we have to take a current time, and we have to call this particular function which we're going to create a short while ago. This will give us the time when we are calling this particular function, means when we are staking the token. Then we'll take this second check, current time is greater than the start date, otherwise we have to throw this error message. Okay, I believe that you guys can understand that what we are doing here. These are the simple check we are doing. Then we have to do the second check. We have to check for the end time. It should be less than the current time, otherwise we have to throw this error message. We don't want that the end time is over and then the user is still staking the token. Then we have to do the third check. We have to say that staking total token and with the amount. If it's more than the maximum, then we don't allow them to stake. So it should be less than the max token limit. Now we have to do the fourth check. We have to take the amount. It should be greater than 0. Otherwise we don't want to allow the user to call this contract. Then we have to do the sixth check. In that we have to check for a condition that amount should be greater or equal to the minimum. Obviously, because you don't allow user to stake 0 token, or minimum is 10 but they are trying to stake 1, so we don't allow them to do that. Otherwise we have to throw our error message, token staking stake amount must greater than minimum amount allowed. So this is the condition we have. Now we can come here. Here we have to do a couple of check. So we'll say if user dot stake amount is not equal to 0. In this if statement, what we are doing, we are checking that if the user is already stake any token in the contract, means he has some contract and he tried to stake the token second time. So that's the case. In that scenario we have to calculate his reward, and in that we have to simply pass this user. Else he's tried to stake the token freshly, so in that we'll call this latest reward calculate, and we're going to pass this current time. So this will give us the time when this particular reward is getting calculated and is going to update in the state variable of the user. Then we'll simply update the user. Okay, now we have to simply take the user stake amount and we have to increment that. Then we'll take the user latest stake time, we have to update that as well. Then we have to update the total stake token in the contract. Then we have to check for the required condition. We'll check that ERC20 taking the interface, then we are taking the token address transfer, and we are simply transferring the token from the user address to the contract address, and we are passing the amount. Simple. Otherwise we have to throw this error message, failed to transfer tokens. Hope you guys are understood that what we are doing exactly here in this particular function. Okay, these are the simple logic we have implemented. Then we have to start the the event, stake event. So this is the entire function we have for the stake, which going to be run internally. And now we have to work on the second function called and now we have to write the function which allow user to withdraw their token from the contract. We have written the staking one, and now we have to write the withdraw the token. So we'll call it function call unstake. It will take the amount external non-reentrancy, and when trajectory has balance means when he try to withdraw the fund, we have to check at least he had some amount in the contract or not. That's why we are calling this modifier. And at the end we're going to return the fund he want to withdraw. We'll call this address user. We have to identify the address. Then we'll say required amount not equal to 0, otherwise we have to throw this error message, because if he doesn't have any fund, then he can't allow to withdraw the fund. Okay, that's a simple logic. Then we have to do the second check. We'll say is staking holder is true, so it will return whether it's true or false. Otherwise we have to throw this error message, not a stakeholder. The third check we have to do is that we have to check for his amount, the amount he tried to withdraw he has or not. Otherwise we have to throw this particular error message, not enough stake to unstake. Then we have to simply calculate the user reward, and now we have to calculate the reward which user have earned so far after staking the token. So we'll say calculate reward, and this is the function we're going to create internally. Just wait. In that we have to pass the user address, and it will give us the balance of the reward. We'll take a UNT variable and we'll say fee early unstake. So we have to take the fee, because if we try to withdraw the fund without completing the period, we have to take our commission. So we can come here, we'll take a if get current time is less or equal to the user last stake time plus 7 the days plus day, since he tried to withdraw the fund before completing the entire time. If that's the case, we have to call this staking amount, and we have to simply multiply with our percentage. So this is the denominator we have defined, and we'll initialize this event. In that we have to pass this amount and close this one. This is the simple check we are doing. We are simply confirming the time, the current time, and the exact time of period. So this one is the simple if statement we have built. First we're trying to get the current timing when the user try to withdraw the token, and we are checking the time which is assigned for the contract to be hold the token. If the current time is less than this one, the exact period, then we have to take our commission, and that's what we are doing exactly here. Then we'll take a UNT variable, say amount to unstake. We'll pass the amount, and we're going to simply subtract the fee because we have to charge that one. And that's the subtracted amount we have to simply transfer. We'll subtract from his balance, and we'll also subtract from the total token staking. And here we're going to say if user stake amount is equal to 0, means he has nothing, then we have to delete the user, because obviously if he has no token hold in the contract, we don't want to show that we have one user who stake the token, because there is no token in the contract. So how it would be possible that we have one user who stake the token? So we have to simply delete that particular user, so it will be 0. Total user minus 1, we have to delete that one. We have to decrease it exactly, okay? Because whenever someone will store their token, it will go up 1 2 3, but whenever someone will withdraw, it will come down. Now we can simply check this require statement, and we have to make the condition. Now we have to check for this require statement. So we'll say ERC20 token. We are taking our interface, then we have to pass the token address, and we have to simply transfer the token to the user. Otherwise we have to throw this error message if anything goes wrong. And then we have to initialize our unstake event, and that's the entire contract we have for the withdrawal, the unstake token. So hope this entire thing makes sense. This is the simple logic we have built. First, we are identifying the user who tried to withdraw the fund. Then second, we are checking his balance. Third, we are checking the time period that when he tried to withdraw the fund, it's in early or he has completed the entire period of the contract. If so, then we are simply, if we try to withdraw the fund before the time periods end, we are charging our commission, and when we are updating the simple state variable. That's the simple logic, and at the end we are simply transferring the fund. And now we have to write the function which allow user to claim the reward. So let's write it. We'll say function claim reward external non-reentrancy, and we'll say when treasury has balance, because these are the two must function we have to use. It's going to return the reward amount for the user. We'll calculate, we're going to create this particular function internally, calculate reward. We'll pass the message.sender. Here we have to take a variable called reward amount, and we'll take this user message standard reward. Then we have to check for a condition reward amount greater than 0. We'll say total staking no reward to be claimed. Then we'll call the second one, because if he has something, then we have to use the interface to transfer the reward to his wallet address. So we'll take this token address, we'll call this transfer method, and we'll pass the user and the reward amount. Otherwise we have to throw this error message if anything goes wrong. Then we have to take the user message.sender reward and set the reward value to 0 in the user struct. And we have to take this message under the reward claim, that how much reward he has claimed so far. So we have to simply pass that amount, and we can initialize our event reward claim reward event. And that's the simple function we have. So first we are checking for it, then we are transferring the reward, then third we are simply updating the user struct, and at the end we are simply starting the event. That's a simple function. So this is the end of the user function which user can call in the front end part. Now we have to build the internal function which we're going to call it internally for calculating of the times and reward. So now we have to create a function which allow us to calculate the user reward. So we'll say function, and it's an internal function. We'll say calculate reward. We have to pass the address of the user, and it's going to simply calculate the reward, and it's going to provide us. So we'll say unt variable unt user reward, and it will say current time, and we're going to simply call this get user estimated reward function, and that we have to simply pass the user address. Then we can simply come here, we'll take this user, because we have to make the reference to the user struct, and there we have to simply update the user reward balance. Then we have to take this user last reward calculation time, we have to update that as well. So this is the calculate reward function we have. We are calling this particular function get user estimated reward. It will give us the reward and the time, and that's what we are simply updating it. Now we can come here, and now we have to write this particular function get user estimated reward, and that we have to pass. We'll say function get user estimated reward, and we have to pass the user address, private view return, and it's going to return the unt variable. We'll say this unt user reward. Then we have to take this user timestamp, and we can get it from the user struct, the last time the reward got calculated. Then we can take this user current time, and we can get it with this function which we're going to create in a while, get current time. Then we have to take if current time is greater than the user last stake time plus the days. If this statement is true, then we have to take this current time, and we have to take this stake time and the day. We have to simply update that current time to the stake time. Then we'll take this total stake time to the current time, and we're going to simply subtract with the timestamp which we are getting from the last one. So that's how we can calculate the difference. Then we'll take this user reward, and we'll say total stake time multiply by user stake amount multiply by the app rate, means the 20%, and we'll say to 365 days. Okay, hope this is clear to all of you, because this is the logic we have built, because we are going with the 20% app rate. So you can define this app rate to any number, but it would be in percentage, so 20%, 40%, 60%. So that's a simple calculation we are doing. We are taking the total stake time, we are multiplying with the stake amount, then we are multiplying with the total app rate, and then we are dividing with the total days, and this will be in the denominator. So this is the denominator we have defined above, and this is the simple calculation. Then we have to do the second check. We'll take this return, then we have to simply return the user reward and the current time, and that's the simple function which will allow us to calculate the fund. So the entire logic is happening. We are simply calculating the reward, and then we are checking for the current timestamp, and then that's what we are returning here. And now we have to write the last function in our smart contract which will allow us to get the current time. So we'll say function get current time, and we'll say internal view return. It's going to return the UND. So all we have to do is to return that. So we'll say block.timestamp, and that's it. So this will give us the current time of the function calls, which we can use in our other function. So this is the entire smart contract we have written. Hope you guys have got an idea. So this is the address contract we have completed. This is the context. This is the ERC20 interface. This is the ownable. We have reentrancy guard. We have the token, our custom token, and this is the staking contract. This is pretty huge. So I believe that you guys have understood every single logic we have implemented here. So try to understand that what we have done exactly here. You guys have understood every single thing we have covered in the smart contract section. So we have written tons of contract and we have utilized in our staking contract. So try to rewatch the video to understand every single thing, that what logic we have implemented. If you have stuck anywhere, try to rewatch to find it out. And with that, we are done with this entire smart contract. In the next video, we're going to start building our context. We're going to build our state management. We're going to build all the logic for our application to be working. After that, we're going to work on the front end side. So let's move to the next video, and that we're going to build our logic for application to interact with our contract.